So just before I kind of close the chapter on science, I thought I'd go over a few kind of problems that arise with science because of its social context and because it does exist within a social context. So I did go over and say it's not itself an ideology, and it isn't, right? But there are all sorts of confusions and kind of ways that science itself can be interfered with because it does need things like funding and the like, right? It needs all of those things. And even science itself, it does, as I mentioned, there is an aspect of it that's kind of almost moral. There are certain virtues associated with science that we're taught throughout our entire lives that we ought to emulate in certain ways. And a lot of the problems that go on with communicating scientific results and the way that it's kind of science is used in public discourse and in politics kind of boils down to some of those aspects. So in science, what are we taught? We're taught never to take things for granted. We're taught to be skeptical of particular positions unless we ourselves have gone out, gathered the evidence, and we've seen the evidence and we know, then we're not really in a position to say that we know scientifically at all. We're not in a position to be able to do that. And in fact, what we ought to do is maintain doubt unless we have absolutely conclusive evidence that such and such theory or such and such position is true. We ought to maintain doubt regarding that. Now that's good for scientists. Scientists ought to be like that. The problem with that is that science itself can't really work like that. Up until a certain point in human history, it was possible to kind of know everything there is to know in science. It was, right? So medieval libraries, for instance, would have had about 30,000 books, I've heard quoted once. That would be your typical medieval library. So in your life, you could have read all those books. But what's the problem? Well, we got really good at science. We have all of these different scientific truths, and you had to start, in order to have enough time in your lifetime to be able to kind of study one component assignment, we had to start specializing in different areas of science. So one person had to be a physicist. So that they could learn all the truths in that particular one, and then further expand and develop our knowledge, our scientific knowledge in that. I had other people who had to be biologists, so not just scientists, but they had to be biologists now. They had to specialize in that, and some had to specialize in subatomic particles and the like, right? And it goes on. And it takes a good number of years to become a specialist in those particular areas, right? You can think about how long it takes to become a PhD. It's like 20, 30 years or so, right? It's a long time. It's a long time to do. So you can become a specialist in that field, and in that field, if you're working in that field, indeed you should be this steadfast skeptic who kind of sees the evidence and the like, right? Because you've been trained in that particular discipline to be able to interpret that evidence. You've done it. It's taken a long time to train you in that way. Now the problem is that every individual nowadays has this kind of scientific idea that they ought to be skeptical of those consequences. But science is a social system, as something that's used to further human knowledge in general can't work that way. It can't. Why? Because no individual can become a specialist in all the sciences. They can't. But we want to take those scientific things that we learn and be able to apply to our lives in some ways to make them better. We want to be able to do that, right? And we want to be able to have that. So although political decisions are not themselves scientific, moral decisions are not themselves scientific, they should be based on the best science available, on an actual understanding of the situation that's going on. And in order to do that, we have to put certain people to become specialists, the scientists in those areas, and we can't put everyone in there at the same time. Because again, there's not enough years in a human's life to become a specialist in everything, and it would just be extremely impractical to try and fund all of that, right? We can't do it. It's kind of an impossible thing to do. Now, there's kind of a miscommunication between, I guess, human beings on an individual level and kind of the sort of skepticism that is virtuous and that's sort of scientific, and science is a social system. And the main point is that, look, although science itself as an actual practice, faith excludes it altogether, and it should be based on the evidence, the scientific truths they come up with. Science as a social system requires faith. I have to have faith that the scientists are doing their job properly. I've got to have faith that they know what's going on. I don't have access to the evidence that they have, so they know better than I do. Even if I had access to the evidence of, let's say, an astrophysicist has, I wouldn't be able to interpret it. It would just be lines and lines of numbers. It would take me years to just be able to figure out what this thing is all about, right? So I've got to kind of take their word for it. And as a social system, in order to bring scientific truth to kind of bear on us, it requires a considerable amount of faith. It does, right? So it's become a bit of a disconnect in that way. Now, the second aspect that almost kind of goes along with that is a misunderstanding and miscommunication about what constitutes scientific proof. And I've kind of gone over that already. Science, as an inductive kind of species of inference, is not capable of providing proof in the way that some people think it does, right? What happens in science? Well, we ought to kind of formulate our opinions regarding the nature of the universe or matters of facts on the basis of the evidence we have available. So there should be correlation between those two. that only ever gives us high degrees of probability. And that's the highest degree of certainty we can get with scientific truth. There's a high degree of probability this is true. You can't say with absolute certainty it is because science does not allow for that. But we can say, based on the evidence that we have, that such and such seems really strongly to be the case. This is as good as we get. Now, in public discourse, there's a miscommunication about that. Why? Because if I say there's a high degree of probability regarding anthropogenic climate change being the case, you're going to say, but you don't really know. You're going to have to prove it to me, right? But I can't do that. I can't do that. Why? Because science doesn't allow that. I sound really watered down when I would explain something like that. And some people would, of course, take that to mean that I don't really know. So you can see how that factors in. Both problems actually probably factor into the climate change debate. And indeed, the example that I think of for both of them is the IPCC. If you've never heard of the IPCC, it's the International Panel on Climate Change. It's a UN body, or a UN kind of sponsored and funded body of climatologists. And these are the best people on the entire planet. It involves nations from all over the planet tracking that data. So there are people all over the planet who are just basically tracking the climate. Best people going. Every 4 years, the IPCC puts out a report kind of on how things are going regarding the climate, right? And of course, over the years, they've been getting worse and worse. Their prognoses for things are warming up faster. We're going to pass that 2.2 degree threshold for a joke this century. Things like that, right? And of course, what happens? Well, people simply don't believe. And why? Because they look outside their window and they see it snowing and say, well, according to the evidence I have, I'm being scientific here. It's preposterous for me to not deny the evidence that I'm getting from my own eyes. And I haven't seen your evidence. You guys are probably skewing the evidence. Now, I mean, yeah, again, not one person could gather all that evidence. And again, your average schmo in the streets wouldn't be able to interpret the evidence anyways. They don't have the expertise to be able to do it. But it's that sort of disconnect that science itself causes. Because again, the person thinks they're being virtuous in saying, look, I deny the IPCC's findings. I haven't seen the evidence. And in fact, the evidence I have contradicts that, right? So they think they're being scientific in saying that. Yeah, the second part of that is when the scientists themselves are actually communicating the results of something like that. They say, well, there's a high degree of probability. All the evidence indicates that anthropogenic climate change is taking place, which somebody not really properly trained in science would say, like, oh, that means you don't really know. Yeah. So we can just reject everything that you're saying, and I'm perfectly justified in believing that climate change is not taking place. But again, that's that sort of social dimension to it that can really skew the way that science is practiced and the way that it kind of has a bearing, or the way that it's accepted by the public at large. There's that. Now, the other issue that I threw in there too regards the way that kind of science is practiced in an institutional setting. Yeah, because of course, when you think of science, what's one thing you think of? Well, it's practiced in universities. There's research and development by private firms, obviously, but universities is the other place that it kind of goes for. And even with R&D, they need funding, right? Funding happens. So there are sort of social irritants or pressures on science itself that can skew science and can really destroy faith in science. So I kind of won't get into that too much, but one of the bigger ones is the p-hacking scandal that took place in recent kind of years over the course of the last decade. The p-hacking scandal, if you haven't heard of it, I think I talked about it before. There's a weird problem, but there's also the p-hacking and repetition scandal that went on. So what I did was I included a link to a CBC podcast dealing with that explains it better than anything else. So, and I'm running long, so I'm probably going to stop this now, and we'll kind of get on our merry way with the semester. So, but yeah, I'll leave it at that.